Here we have a wave of a certain amplitude that I'm going to call A. And if we consider a very similar wave that has the same wavelength but maybe a different amplitude, so maybe half the amplitude, and this is quite a tricky thing to draw during a sine wave, but it's worth practicing. That's not bad, is it? If this other wave has an amplitude of half of the other one, we can look at the difference in the intensity or the power of these two waves. Now, the intensity of an object is a measure of the amount of energy per second per square metre. So the intensity is equal to power over the cross-sectional area. So if we think about intensity, I maybe have the light on a phone. Now if I shine it if I put all of that energy onto one small area, it's going to be quite an intense brightness. As that energy is spread out over a larger and larger area, we can say that the intensity of the light is going to be less and less. So the intensity equals power over area. And actually what we find is that the intensity isn't proportional just to the amplitude. We can look at maybe the difference in the area under the wave here for the small blue one, and if we compare that area to the whole thing, the area of the blue one is about a quarter of that. What this shows is by looking at the area underneath the curve for the amplitude of the small blue wave, that's quite small compared to the very large area for the higher amplitude. And what we can draw from this is that the intensity is proportional to the amplitude squared. It's not just proportional to the height. A wave with double amplitude carries 4 times as much energy.